In this step, we are filling the bottom of each beaker with selected test material. We make sure each material reaches a height exactly 2.2 cm to maintain a fair test. Every material is packed tightly to minimize air pocket, ensuring that our measurement of these insulating properties are accurate. For the heating process, we set the hot plate to low temperature of 60 degrees Celsius to ensure a controlled and safe experiment. Once the temperature was stable, we placed all 5 beakers into the hot plate at the same time. This stage, we placed one ice cube into each beaker and monitoring them closely. We used stopwatches to record the exact time it took for each ice cube to melt completely. By gathering this data, we can determine the effectiveness of each material, where the one is the longest melting time is considered the best insulator. Based on our data, tissue is the best insulator because it recorded the longest melting time, which is 2,598 seconds. This is followed by newspapers and styrofoam, while solution turned out to the worst insulator with the fastest melting time, only 450 seconds. That's result proof that different materials have different level of thermal resistance, as the material with the longest melting time successfully slow down the heat transfer from the hot plate.
Based on data, which material turned out to be the best insulator? Why? Tissue is the best insulator with the longest melting time. It's because fibrous structure traps air pockets, creating low thermal conductivity that effectively blocks heat. Based on data, which material turned out to be the worst insulator? Why? Shaving cream is the worst insulator with the shortest melting time. It's because high water content and high density allow heat to conduct through the material rapidly. As an engineer, what conclusion might we draw from our data? As an engineer, the conclusion is materials with trap air or fibrous structures like tissue and newspaper are superior insulators compared to dense or moist materials, as they minimize heat transfer. How did results differ from prediction we made before conducting the experiment? We initially predicted styrofoam would be the best insulator. However, tissue performed better, likely because it was more porous or had a greater effective thickness in the setup. What were some controls in this experiment? Some control in this experiment is hot plate temperature 62.5 Celsius, ice cube size and insulation thickness 2.25 cm constant.
What method of heat transfer caused the ice to melt? The ice melts primarily due to conduction. Heat is transferred from the hot plate through the glass beaker and the insulating material directly into the ice cube resting on top. What heat processes, convection, conduction, or radiation do you think are most prevalent in and around the beaker? In my opinion, all three heat processes are present in this environment. Firstly, conduction. Heat moving from the hot plate through the beaker and the insulation. Second, convection. Warm air rising around the hot plate and the beaker, as well as the potential air movement within the beaker if the insulation is not packed tightly. And lastly, radiation. Heat being emitted from the surface of the hot plate to the surrounding air and the beaker walls. How does this experiment help us to determine the best insulator? This experiment measures the effectiveness of material by timing how long it can prevent heat from reaching the ice. Specifically, the material in the beaker with the longest melting time is considered the best insulator because it resisted the heat transfer from the hot plate most effectively. Next, by keeping the volume of material precisely exactly 1 centimeter, the result can be fairly compared across different materials. How you might improve this experiment? First, minimize the air gaps to make sure the material is packed even more tightly. Second, control the external variables. Third, measurement accuracy. Use a scale to weigh the ice cubes as they melt rather than just timing them.
For question 10, apart from material tested, this experiment can be used to test other insulating material such as plastic, rubber, fabric, foam and cardboard. In addition, different thickness of the same material can be tested to study how material thickness affect heat insulation performance. So that what are some cause of error from the hot plate? Okay, common possible source of error from the hot plate include uneven heat distribution, temperature fluctuation during the experiment, and inconsistent contact between the beaker and the hot plate surface. For question 12, in engineering, why it is useful to know the insulation properties of different material? So in engineering, understanding the insulation properties of different materials is important to improve energy efficiency, reduce heat loss, ensure safety, and select suitable material for use in building, machine, and industrial application. The last question is common attribute of insulating is the first one is low thermal conductivity. Second, ability to trap air within the material structure, and for heat